Okay, so in this video, I will discuss some of the tutorial problems from diffraction. Okay, so the first question is: a plane grating just resolves two lines in the second order. Calculate the grating element if d lambda is equal to 1 angstrom and the lambda is equal to 6000 angstrom and width of the grating is 2 centimeter. Okay, so how we can solve this problem? Yes, so as per the question, so I think while we study the diffraction grating, the solving power, and when the diffraction grating itself, we have seen that when we use white light, so the first and second order we can see the component colors. For example, white light is now passing through this grating, so we can see the diffraction pattern here. The first order diffraction, central maxima. So that will be, if we use white light, for example mercury light, it will be white. The central maxima will be white, and on either side of central maxima we can see the first order principal maxima. Those first order principal maxima contain VIBGYO. Okay, so violet, indigo, blue, green, yellow, orange, like that here as well. Okay, so if we consider any two such lines, spectral lines, so that is what it is written here. So this is for first order, is equal to 1, and the second order also we can see the VIBGYO. But the thing is, here the intensity will be that's lower than the first principal. First principal maximum. So that is n is equal to 2. So the question is, a plane grating just resolve two lines in the second order. Okay, so in two lines, maybe we can see if it is an yellow line. So the yellow line can be seen, yellow 1 and yellow 2. So two lines will be there. So that we can see while doing the experiment in our laboratory. So while looking through the spectrometer, we can see the splitting of the two spectral lines. For example, for yellow and also for red. So for different spectral lines, we can see a gap between, or we can see the plane grating resolves two spectral lines. Okay, so in that case, that is what it is written here. So the separation between these two lines, that is d lambda, it is equal to 1 angstrom. That is what it is given here, and the corresponding wavelength is lambda 6000 angstrom. So 6000 angstrom is around yellow is around red, right? Orange is around 580 to 600, and from 600 you can see the red color. So yes, lambda is equal to 6000. So those are the things. So we can write those things. So the question is, calculate the grating element if d lambda is equal to 1 angstrom. Okay, so how we can do that? So let's write the given parameters. So d lambda is equal to 1 angstrom. So I hope you understand what is d lambda. and lambda is equal to 6000 angstrom, and also the given thing is it is in the second order, right? The second order. N is equal to 2. So calculate the grating element. So that is the equation. We know grating element equation, right? Grating element, what was the equation? Grating element D is equal to 1 by N. What was N there? Yeah, the number of lines per unit length, right? That we have studied during the theory class. Okay, so how we can find out this term D? Okay, so how we can find out? Because we have d lambda here, yeah, we have a lambda here, and we have n here. So from these data, how we can find the grating element, or how we can find n? So do you have any idea how we can find n? Yes, how we can find it? Yes, we have the resolving power equation from, you can get the resolving power equation from lambda and d lambda. What was the resolving power equation for a grating? Resolving power. What was the equation? Yes, it is equal to lambda by delta lambda or d lambda. Okay, so lambda is given here. What was the lambda? 6000, and d lambda is there. So there is a connection between, there is an equation to find the resolving power. What was the equation? Yeah, it was n0. What is n0 here? Yeah, n0 is the total number of lines that we have explained in the theory class. N0 is the total number of lines in the grating. So what is n here? Yeah, n is, what is n? Yeah, n is the number of, what is n? Number of lines per unit length, right? So from here, how we can find out the value for n? Yeah, so we have this equation, right? From here, what we can find? We can find out n0. So once you can find n0, that is the total number of lines. Yeah, we can find the number of lines per unit length. Okay, so let's see how we can find it. Okay, so here n0 is equal to, from this equation, what is n0? Yeah, lambda by, yeah, n into d lambda, lambda by n d lambda. So what will be the value? What is lambda? 6000 angstrom into 10 raised to minus 10 divided by, yes, 2 into what is d lambda? 1 angstrom, 1 into 10 raised to minus 10. So what will be the value? Yeah, 10 raised to minus 10, 10 raised to minus 10 cancel out. 6000 by 2, that is 3000. So that means the total number of lines is 3000, right? So we need to find the value of the grating element. We need to find number of lines per unit length. Number of lines per unit length, n, that is equal to, how we can find it out? Yeah, so from the question we have the total width of, or total length of the grating, that is 2 centimeter. So if we have a grating, yeah, grating is here, so it is having 2 centimeter. So in 2 centimeter it is having 3000 lines. So that is the meaning. 2 centimeter, 3000 lines. So then it is easy to find out number of lines per unit length. So what will be the answer? Yeah, total number of lines, that is 3000 divided by, yeah, the total width of the grating, that is 2 centimeter. Right. So that means, yeah, 1500 lines per centimeter. Okay, so from here we can find the grating element. Grating element yes, D is equal to 1 by n, that is equal to 1 by 1500 lines per centimeter, right? So lines per centimeter, so that is actually 1000 lines per 1 by divided by into 1 by 10 raised to minus 2. So that 10 raised to minus 2 will come up, so it will become 10 raised to 2, right, meter. That is equal to, it's around, you use your calculator, so this is around 6.67 micrometer. So the grating element is 6.67 micrometer. Okay, so I think the question that I have given to you is something different, and the width is around 3 centimeter and the d lambda is 2 angstrom. So I think you understand how to solve this problem. Then you can substitute those values for d lambda and the width, so you will get the answer for that particular question. So I hope it is clear. So if it is clear, we will go to the next question. Okay, so the next question is, what is the highest order spectrum that may be seen with the light of wavelength 5000 angstrom using a grating with the 3000 lines per centimeter? Okay, so in that case, actually, so what will be the highest order spectrum that may be seen with a light of wavelength 5000 angstrom using a grating with the 3000 lines per centimeter. So actually, if we use a grating and we need to get the highest order spectrum, so there we have seen the central maxima, first principal maxima, second principal maxima, third principal maxima lines, right, on either side. So the question is, here is the our grating. So ray of light is passing through here. So that means the highest order spectrum is actually, this is n is equal to 0, n is equal to 1, n is equal to 1, n is equal to 2, this is n is equal to 3, like that, n is equal to 2, n is equal to 3. So it will go like this. Okay, so that means the order is going like this, right? So the highest order spectrum means what will be the position. The position of that highest order is determined by the angle it make with the normal, right? So this is a normal, so the maximum angle will be this angle, that should be 90 degree for a highest order spectrum. So the maximum angle of diffraction for a highest order spectrum is, that is 90 degree. So we can write the given things here. What are the given things? Given lambda is equal to 5000 angstrom, number of lines per unit length, n is equal to 3000 lines per centimeter. So it is the highest order spectrum, so the angle of diffraction will be maximum, that is 90 degree. So the maximum angle of diffraction is the highest order spectrum, the maximum angle of diffraction. Diffraction is theta is equal to 90 degree, right? So we have the grating equation. What is the grating equation? What was the equation? Sin theta is equal to n. Sin theta is equal to n lambda. So n is here, lambda is here, theta is here. So what will be n? That's what we need to find, right? The highest order spectrum. N is equal to sin theta or sin, we can write sin theta by n lambda. So for highest order spectrum, n is equal to, or n maxima is equal to sin 90 by I. What is n? 3000 lines per centimeter into that is actually lambda is 5000 angstrom, that is 5000 into 10 raised to minus 8 centimeter, because n and is in centimeter, so you can write lambda as in centimeter. So what will be the answer? 5000 into 10 raised to minus 8. So it is equal to 1 by 3000 into 10 raised to 5 into 10 raised to minus 5. So you can use your calculators, around 6.666. So the highest order is 6. The highest order is 6. That means for this particular grating having 3000 lines per centimeter, and with light 5000, having wavelength 5000 angstrom, the highest order that we can see is 6. So actually this experiment we can do with our point laser, so that we can we can do in our laboratory or in class. So once you come back to college, we can do this kind of experiment, and you can see the diffraction pattern. So there is an experiment actually. So while doing the experiment, you can see the number of orders on either side of the central maximum. So it says it can go up to 6. The maximum number is 6 for this particular grating and for that particular wavelength of light. Okay, yes. So then we move to the next problem. Okay, the question is light of wavelength 56 nanometer falls normally on a grating 20 millimeter wide. The first order is formed at 18 degree from the normal, and what is the total number of lines in the grating? Okay, so here actually the source given, we can write given things. Lambda is equal to 656 nanometer, right? And the width of the grating is width of grating, we can say x is equal to 20 mm. Okay, that is 20 into 10 raised to minus 3 meter. Right. Okay, so the first order is formed at 18 degree from the normal. So what is that meaning actually? So this is the central maxima and the principal first order, principal maxima. So this is the first order, right? This first order is, this is a grating, this is grating. Okay, so the ray of light is incident normally on the grating. Okay, so there is a normal here. So along the normal we can see the central maxima. So this is the angle which make the first order with the normal. So this is the angle. So this is called here it is 18 degree. This is called the angle of diffraction. Okay, so theta is, the angle of diffraction is 18 degree. So we need to find the total number of lines in the grating. Total number of lines is n0. We need to find n0. Okay, so from this equation, theta, lambda, and order also there. What was the order? N is equal to 1, first order. So we can write the equation for grating equation. Sin theta is equal to n lambda, right? Sin theta is equal to n lambda. From here we can find the value value of n, that is lines, number of lines per unit length that we have discussed in the previous problem. So n is equal to sin theta by n lambda, right? So what is the value? We can have n is equal to sin 18 divided by n lambda. What is n? yeah, 1 into lambda 5, yeah, 656 into 10 raised to minus 9 meter. So sine 18 you have to calculate from, find it from the calculator. So we need to find the total number of lines in the grating. So the total number of lines in the grating is actually total number of lines in the grating, and is equal to, yes, you can write total number of lines in the grating is equal to number of lines per unit length into into a total length of the grating or total width of the grating, the width of the grating. So that means n0 is equal to n into x, that is equal to, I need to find what is the value of sine 18 divided by 1 into 656 into 10 raised to minus 9. So, and we need to multiply that n with what is x? 20 into 10 raised to minus 3. So something around, that was answer 9421. So that is the total number of lines in the grating. So that is a good problem, and I hope it is clear. So you have to calculate it with the calculator. I don't have a calculator with me now. Okay, so okay then. So I hope it is clear. So please calculate the value of n with the calculator and substitute here and multiply with the 20 millimeter. So we get these answers. The answer is here actually. Okay, so we'll go to the next problem. Yes, question is a grating has 6000 lines per centimeter. 6000 lines per centimeter. Find the angular separation of the two yellow lines of mercury wavelength 577 nanometer and 579 nanometer in the second order. So that is actually that we can see while doing the experiment. So yeah, we can see two lines, two yellow lines having 577 nanometer and 577 and 579 nanometer. So two lines can be observed while we looking through the telescope. So two lines in the first order as well as in the second order. So as you have seen, the resolving power increases with respect to the order that we have seen the previous equation of lambda by d lambda is equal to n0. So depending on the value of n, the resolving power also will increase. Okay, so yeah, we'll do the equation anyway. So a grating has 6000 lines per centimeter. So find the angular separation of the two yellow lines of mercury wavelength. So we need to find the angular separation between these lines. Actually, if we consider so actually, as I have this is the first order, central maxima, second order. So in second order also we can see the VGO. Okay, so in the second order, so that is a question. So there is two yellow lines. Okay, so what is the what is the angular separation of two yellow lines of but these two yellow lines. So here under yellow line, so sorry, these two yellow lines make some angle with the normal. So there is some, yeah, so if we take it, there is some gap between these two lines which make angle with the normal. So here is a grating, so it's incident light. Okay, so we need to find this angle of separation between these two yellow lines. So how we can find that? So first of all we can write what are the things given. So here we have the number of lines per unit length. We'll use yes, n is equal to 6000 lines per centimeter. Lambda 1 is equal to 577 nanometer, and lambda 2 is equal to 579 nanometer, and this is second order. So these are the things it is given here, right? So we can write equation for that. So we need to find, actually we need to find the angle of diffraction for each lines. Okay, so we can just substitute, so we write that equation or grating equation. So sin theta is equal to n lambda. So suppose theta 1 is the angle which make this yellow one line with the normal, so we can take it as sin theta 1 is equal to n lambda 1. And if theta 2 is the angle which make the second line with the normal, so we can mark it as theta 2, right? So we can write sin theta 2 is equal to n lambda 2, right? Yes. So if we calculate that, so from here we can calculate theta 1 is equal to sine inverse, we have a n here, 2 into 6000 lines, 6000 raised to 2 lines per centimeter, right? So that's why this 2 raised to 2 into, yes, yeah, 570, yeah, okay, anyway we can take 579 or 577, whatever be the 577. So and nanometer, 10 raised to minus 9. So it is around, we take it's around 44 degree. Sorry, it is around 40. Yeah, 43 degree 49 minutes. Okay. Similarly, theta 2 can be find out. Sin inverse is equal to 2 into 6000 raised to 2 into 579 raised to minus 9. So that is around 44 degree. So the angular separation is, that is what we need to find out. Angular separation is is equal to theta 2 minus theta 1. So that is around 11 minutes. Okay, So I hope it is clear. So I hope you understand what is the meaning of angular separation, and so yeah, how the lines, each line make angle with the normal, and yeah, the corresponding angle of diffraction for each line. Okay, so that is the basic idea of this problem. So we will go to the next problem. Okay, so the question is, for a plane diffraction grating with 5000 lines per centimeter used at a normal incidence, answer the following. For a plane diffraction grating with 5000 lines per centimeter used at normal incident, answer the following. First one is, what is the largest wavelength of light for which a spectrum can be observed? And second problem is, for a wavelength of 6000 angstrom, what is the highest order of spectrum that can be observed? So the second part is actually that we have done already, such kind of a problem. So the first part is actually is a new one. So let's do it. Yeah, the given parameter is a grating, and number of lines per unit length is 1000 lines per centimeter. Right, and first question is, yes, what is the largest wavelength of light for which the spectrum can be observed? What is the largest wavelength of light for which spectrum can be observed? So what we know, yeah, we have the equation, that is what we have in our hand, the grating equation. Sin theta is equal to n lambda. So what is the largest wavelength? So lambda will be maximum. So we need to find the condition where when the lambda will be maximum. So we can write the equation for lambda from here. Sin theta by nn. So that means from this equation it is clear that, yeah, for maximum wavelength, lambda is maximum when theta is equal to 90 degree. That is the maximum value of sin theta, right? And what will be the n? So n should be, the order should be minimum. N is equal to 1. Should be minimum. Okay, so for a given grating, so that is a condition. So lambda is maximum means, if lambda is to be maximum, sin theta should be having the maximum value. That is, sin theta having the maximum value, that is equal to 1, right? Maximum value is 1 for sin theta. So that is when theta is equal to 90 degree. And also the denominator should be minimum. So that means n should be minimum, because n, capital N is a constant here. That is already given, right? 5000 lines per centimeter. So this is the condition. So we can write lambda maximum is equal to, yeah, sin 90 divided by 1, n is equal to 1, and 5000 lines per centimeter. That is 5000 10 raised to 2. Okay, so that is equal to, yeah, it's around 20,000 angstrom. Okay, yes. So that is the value. The lambda maximum is around 20,000 angstrom. Okay, so 20,000 angstrom is it's actually into 10 raised to minus 10 meter. That is around 2 into 10 raised to 6 meter. Okay, so this 40 will go, and we get 10 raised to minus 6. 2 into 10 raised to minus 6. That means 2 micrometer, around 2 into 10 raised to minus 6 meter. Right. Yes, that is not 2 micrometer. So that is a maximum wavelength, right? So we were discussing with the in a nanometer wavelength. Okay, so next question is so that such a kind of question we have already done in the second part. For wavelength of 6000 angstrom, what is the highest order spectrum that can be observed? So the previous problem we have seen, for highest order, theta should be 90 degree, right? For highest order, yes, theta is equal to 90 degree. So if you didn't understand, please watch the previous problem that I have explained how this 90 degree comes for highest order. Okay, so that is n is equal to, so we need to find the value for the n value, right? So how we can find it out? N is equal to sin theta by n lambda, and sin 90 by what is n? 5000 lines per centimeter into lambda. This is for 6000 angstrom. 6000 into 10 raised to minus 10. So the value will be around 3.3. Okay, so the highest order spectrum, we can take it complete way. So the highest order is 3. Okay, so I hope it is clear. This is also a very good question, and I hope it is clear. So we'll go to the next problem. The question is, how many lines per meter are there in a plane diffraction grating which gives in the second order an angle of diffraction 30 degree for light of wavelength 520 nanometer incident normally on it. So that is a very simple problem actually. We can just directly substitute the values and we will get the answer. So the given things we need to write. Given lambda is equal to 520 nanometer, right, and the theta is equal to 30 degree. So, and this is for how many lines per when diffraction grating gives second order, right? In the second order, n is equal to 2, right? So these are the things given. So we need to find, or we need how many lines per meter are there in a plane diffraction grating. So that we what we need to find? We need to find n, number of lines per unit length, right? But we need to find it in meter. So how we can find out n? So we have the equation sin theta is equal to n and lambda. So n is equal to sin theta by n lambda. Substitute the values here. So the theta is sine 30. Sine 30 divided by n is equal to 2 and lambda is 520 nanometer. 520 into 10 raised to minus 9 meter, right? So it's around, yeah, 4. You have to calculate sine 30 divided by 2 into 520 into 10 raised to minus 9. It's around 580.8 into 10 raised to 3 lines per meter. Okay. Okay, so yeah, these are the lines, and so if you, yeah, I hope it is clear. So if you have, so we'll go to the other